Hello everyone. In this video, we will understand about the circle concept, which is a class 10th topic. Including that, we will understand about tangent, chord, the theorems of the chapter number 10, and the examples of exercise 10.2. So stay tuned with this video till the end so that you are able to understand the complete concept in one video. Hello my awesome students, welcome back to my channel Akshar. I am Nina and I usually make videos related to NCERT solutions for classes 9 to 12. So stay tuned with me.
So let's start theorem number 10.2, which says that the length of tangents drawn from an external point to a circle are equal. Right? What does it say? That there is a circle and two tangents are drawn on the circle. That means two lines are drawn on the circle which are touching the circle at a single point, right? So let's say this point is Q and this point is R, and these tangents are drawn from a single external point. External point means the point which is outside the circle. So this point P is outside the circle, and from this point P two lines are drawn, two tangents are drawn, which are named as PQ and PR. So we have to prove that the length of their tangents means PQ is equal to PR. Right? So what is given to you? Given is a circle with two tangents drawn from external point P. Okay, what we have to prove? To prove is that we have to prove that PQ is equal to PR. Okay, so let us start our proof, which says that how we will prove that our PQ is equal to PR. If I see the triangles, in triangle there are two triangles, OPQ, OQP and ORP. There are two triangles, right? In these two triangles you can see that OQ and OR are my radius. OQ and OR are radius. So OQ is equal to OR. Why? Because both are radius of the circle. Okay, so both are equal. Next, OQ is equal to OR, both are equal because both are radius of the circle. What we can say that next, that my OP is a common line in both the triangles. OP is equal to OP. Why? Because it is a common line. Okay, so from these two theorems, what it says that my triangle OQP is congruent to my triangle ORP. Okay, so by Cpct rule, you know that if any two sides of the triangle are equal, then both the two triangles are congruent to each other. Okay, so what does the congruent property says? That the corresponding sides are equal to each other. That means OQ is equal to OR. First result will be this one. OQ is equal to OR. We already know about this result because both are radius of circle. Okay, next result, QP is equal to RP. QP is equal to RP, or I can say that PQ is equal to PR. This is the result which we need to prove in this theorem. And the third result will be what? OP is equal to OP, which we also know already because it is a common side. So this is the result which we have proved by using the Cpct property of two triangles. So which says what? So the theorem says that length of the tangents drawn from any external point onto the circle are equal. If you draw any two tangents from any external point, with any point which is outside the circle, so the tangent's length will be equal. That means PQ will be equal to PR. Let's start solving example number 1, which says prove that into any concentric circle. So concentric circles are what? First you have to understand that what are the concentric circles. Concentric circles are those whose center is going to be same but their radius will be different. Okay, so these type of circles are called as concentric circles, right? Then the chord of the larger circle. Chord is what? Chord of a circle is what you have studied in class 9. Any line which is inside the circle, this type is called as chord. This line is will be called as chord, right? So I am going to draw the chord for the outer circle, for the larger circle, right, which touches the smaller circle, which is touching the smaller circle, is bisected at the point of contact. So what it says, point of contact is what? The point at which it is touching the circle. At this point this chord is bisected. Bisected means, bi means two, sected means sections, means two equal sections are formed, means two lengths are equal to each other. Okay, so let us suppose the center of the circle is O, and suppose this is B, this is P, and this point is Q. Okay, so what is given to me? Given to me is two concentric circles. Two concentric circles are there, and chord of outer circle, chord of larger circle touches the smaller circle, at point Q. Okay, so what I have to prove? I have to prove that this point, at this point of contact, BQ is equal to QP, right? So let's start our proof. In theorem number 10.1 we have studied that, so this BP is what? Because it is touching the inner circle at only single point Q. So BP is what? BP is tangent to the inner circle, right? Because it is touching the inner circle at only one point, which is Q. Point of contact is what? Q only, right? So we have studied in theorem 10.1 that any radius of the circle drawn on the tangent with and if it is a point of at the point of contact, it makes an angle of 90 degree. That means OQ is perpendicular to BP. We have studied in theorem number 10.1. I have explained this in my previous video. Okay, so if you have not seen my previous video about the circles, so please see that first, right? So moving to this part, OQ is perpendicular to BP. Okay, so since BP is what? BP is chord of outer circle, right? So you have studied in your class 9th that if you have studied in your class 9th that any perpendicular on the chord bisects that chord. Okay, that means OQ is perpendicular to BP. That means OQ is bisecting what? OQ is bisecting the BP, right? So this we have to prove that OQ is, if OQ is bisecting the BP, that means Q is the midpoint of BP. If Q is the midpoint of BP, that means OP, that means BQ is equal to QP. Okay, so we have used two theorems while solving this example. The very first is the theorem number 10.1, which says that for this we have used the concept of tangent with the inner circle, and the second theorem which you have studied in class 10th is related to the chord and the perpendicular. Okay, so any radius with the point at the point of contact to the tangent is perpendicular to the tangent, that means OQ is perpendicular to BP. Then what we did, we converted our equation with respect to outer circle. First we used inner circle concept and tangent concept, then we used outer circle concept and the chord concept. Okay, so moving to example number 2. So two tangents TP and TQ are drawn to a circle with the center O. So center is O and there is any external point T. So two tangents are drawn from this external point. Suppose this is point P and this is my point Q. Okay, so we have to prove that my angle PTQ, this angle is 2 times my angle OPQ. So let us join these lines. Angle OPQ. So this angle, I have to prove that this angle is twice of this. Okay. So to prove that, what we will do? So first we will write down our given. Given is what? Two tangents TP and TQ drawn from an external point to a circle with the center O. Okay, so this much is given to us, right? And what we have to prove? To prove is that angle PTQ is equal to 2 times of angle OPQ, right? So let's start our proof. Let us suppose our angle PTQ is equal to theta. So you can imagine any value. I have assumed that my angle PTQ is equal to theta, right? So by the theorem 10.2 we have proved right now that if any two tangents are drawn to a circle from any external point, then the length of the tangent is equal. That means TP is equal to TQ. What you will write down the reason? That because tangents drawn from any external point to the circle are equal, right? So that's why our TP is equal to TQ. Do not write down in the exam that because of theorem number 10.2, right? No one is going to give you marks. You have to explain the reason in your exam, right? So now since TP is equal to TQ, that means my triangle TPQ will become an isosceles triangle. Isosceles triangle is what? Isosceles triangle is a triangle whose two sides are equal. So TPQ will become my isosceles triangle because TPQ, you can see very clearly TP is equal to TQ. So if two sides of any triangle are equal, then that triangle is known as what? That triangle is known as isosceles triangle, right? So again we will use another property of isosceles triangle, which says that two opposite angles are also equal. Angles opposite to the sides are also equal. So opposite to this side is this angle and opposite to this side is this angle, right? So that means angle TPQ is equal to angle TQP, right? Because of isosceles triangle. Okay, so let us suppose this is my equation number 1, right? Now in any triangle, suppose if the triangle is my TPQ, sum of all the angles, which is theta, plus these two angles which are equal to each other. Let us suppose this angle is x, so this will be also my x. So what does the sum triangle property says? Theta plus x will be equal to 180 degree. So theta plus 2x will be equal to 180 degree. So that means my angle x will be equal to how much? 2x will be equal to 180 minus theta. So my x will be equal to 180 minus theta divided by 2. So that means my angle, this angle, I have assumed this angle now. So that means my angle TPQ is equal to angle TQP, which is equal to half of 180 degree minus theta. So that means my angle TPQ is equal to angle TQP is equal to 90 degree minus half of theta, right? So this was my diagram. I am going to draw it again for you. So this is O and this is T, this is P and this point is Q, right? Okay, so now again, by using the concept of theorem number 10.1, which says that any radius drawn on the tangent at the point of contact is perpendicular, right? Perpendicular to the tangent. So OP is a radius and P is the point of contact of this tangent. So that means OP is perpendicular to TP, tangent. That means this OP is making an angle of 90 degree. This complete angle will be of 90 degree. That means angle OPT will be equal to 90 degree, right? So give this as equation number 2. So OPT is what? OPT is, you can see from the figure that OPT is made up of two angles, which are what? OPQ, angle OPQ plus angle OPQ plus angle TPQ, right? TPQ, which is equal to 90 degree. Okay, so what I have to find out? I have to find out this angle OPQ. So angle OPQ is equal to 90 degree minus angle TPQ. So from equation number 2, if I will put the value of this equation number 2 in this third equation, then what I will get? I will get angle OPQ is equal to 90 degree minus half of minus 90 degree minus half of theta, which will give me 90 degree minus 90 degree plus 1 by 2 of theta. So 90 and 90 will get cancelled out and I will get half of theta. And theta is what? We have imagined theta as this angle. That means the angle PTQ. So it will give me angle PTQ is equal to OPQ, right? So if I will do cross multiplication, then what I will get? 2 times of angle OPQ is equal to angle PTQ. So this was the thing which I have to prove, that angle PTQ 2 times of angle OPQ is equal to my this angle PTQ.
If you find this video useful, then please do like, share and subscribe my channel so that you can get updates of my new videos. So let's meet in the next video, in which we will solve the remaining examples of exercise 10.2. Till then, take care and bye.